Here we're going to look at the 8 different questions in exercise 12.3. Our key formula for these questions are these 4 here. So we have our 2 different formulas for centripetal force and our 2 different formulas for centripetal acceleration. You'll decide which one to use based on the information you're given. So force is equal to mass by velocity squared over radius, or acceleration is equal to velocity squared over radius, and then alternatively your force is mass by radius by angular velocity squared, or your acceleration is r by omega, radius by angular velocity. In these 8 questions we're told to take gravity as 9.8 meters per second squared. So in the first question, a car of mass 1,200 kilograms travels around a circular track at 25 meters per second. If the radius of the track is 200 meters, find the centripetal force. So again, we take out the information. Mass is 1,200 kilograms, do not convert. Velocity is 25 meters per second. The track is 200 meters, so that's our radius, so we have r equals 200 meters. Based on this information, we're going to use this first formula that F is equal to m by v squared over r. We simply sub in our values then. Remember to square it, it's a common mistake, and we get our answer for force. In our second question, we're asked to find the centripetal force on a mass of 4 kilograms, which is moving in a circle of radius 20 centimeters, with a constant angular velocity of 4.5 radians per second. So again, we pick out our information. Our mass is 4 kilograms, our radius is 20 centimeters, which we convert to 0.20 meters, and our angular velocity omega is 4.5 radians per second. The most suitable formula here is F is equal to m over omega squared. So we have the information for this, so we just sub in our mass, our radius in the SI units, and our angular velocity, and we get 16.2 newtons. Thirdly, and then again there's a couple of parts to this, find the centripetal acceleration of a particle moving in a circle with a speed of 12 meters per second if the radius of the path is firstly 1 meter and secondly 30 centimeters. So we have our centripetal acceleration is what we're asked to find, so that's going to be A. We have a speed of 12 meters per second, so that's our V, and in the first question our R will be 1 meter. So we're going to continue on with this, and we have our question here. So we're looking for our acceleration. So the easiest way to use when we know V and R is A is equal to V squared over R. We sub in our values, so we get 12 meters per second squared over 1 meter, which our acceleration is 104 meters per second squared. That should be a -2 there, or a division line in between. In the second one, we're again looking for acceleration. Our velocity is still 12 meters per second, but our radius is 30 centimeters. So that's switched to 0.30 meters. We sub in our values and we get 400 meters per second. So again, here you can see with the smaller radius, we get a much bigger answer. This next part of the same question is we're asked to find the centripetal force acting in each case if the mass of the particle is 5 kilograms. So this is some new information added in. So the mass is 5 kilograms. We can use either way. We can go from the first place and use this formula, F is equal to mv squared over r, just like we did before, but we've already found this v squared over r part. That v squared over r gives us our acceleration. So we can just use F is equal to ma, because this here is equal to a, so we can sub that in. So we can take our acceleration found from the first part of the question, which is 104 meters per second to the -2, multiply by the mass of 5, and we get our force of 720 newtons. In the second question, we have the acceleration of 480. So F equals ma, our mass is 5 kilograms, we get 480 meters per second, and we get a force of 2,400 newtons. So again, there's a much bigger force needed for the second one. So note, it takes, or it has a lot more force to hold the closer object. So you need a lot more force, or it takes a lot more force, or there is a lot more force. So in this case, that will be more tension in the string or rope. Other questions, it might be more gravity or more friction or something like that. But the smaller radius greatly affects how much is needed to hold the thing in its circular path. On to question 4. We're told a mass of 10 kilograms moves in a circular path with radius 40 centimeters with a constant linear speed of 4 meters per second. Find first off its angular velocity, then its centripetal acceleration, and then the force acting on it. So again, we go through, we have a mass of 10 kilograms, circular path of radius 40 centimeters, so we switch that to 0.4 meters, and then we have the constant speed of 4 meters per second. I did this one a little bit higgledy-piggledy. But we'll look, the first thing we're going to do is the angular velocity. The first thing I actually found was the centripetal acceleration, so I've done it a little bit differently than probably how they wanted. So first, find the centripetal acceleration. The formula for that, omega is equal to v squared over r. We know v sorry, it's just V over R. We know V, we know R, so we substitute in those, so we get 10 radians. Then we can find the centripetal acceleration. I've used the same formula we just used. A is equal to V squared over R. We sub in my V, square it, divided by R, which is 0.40 meters, and we get the angle of 40 meters per second. The other way we could have done this was the acceleration is equal to R omega squared. So if we did that, we get the same answer of 40 meters per second. Finally, we're asked to find the force acting on it. So again, just like before, once we have the acceleration, we can use F equals ma. So we have the mass of 10 kilograms multiplied by 40 meters per second. So we get a force of 400 newtons. Then that will be the centripetal force acting towards the center. Question 5. A car of mass 950 kilograms travels around a circular bend of radius 100 meters at 100 kilometers per hour. What is the force on the car towards the center of the circle? And even notice this, if you go around the bend in a car or on a bus, you will be pushed to one side, so that's the centripetal force acting. So our mass is 950 kilograms, our radius is 100 meters, our velocity is 100 kilometers per hour. And while that's the usual unit of measurement for a car moving, we're going to have to convert this into meters per second. So we take this 100 kilometers per hour, we divide it by 60 to get minutes and by 60 to get seconds. So that is that many kilometers per second. Then we multiply it by 1000 to get meters, and we get the answer that our velocity is 27.77777 meters per second. We're looking for the centripetal force, so we're going to use this formula because we have the velocity, mass by velocity squared over radius. We sub in our figures, we got our mass. We've just found our velocity in meters per second, 27.7 recurring, and we divide it by the radius, which again we're told is 100 meters. So we sub in all of that information and we get that the force is 7,330 newtons, and again remember to include your answer. Question 6 then, a bicycle wheel turns with an angular velocity of 20 radians per second. If the radius of the wheel is 0.5 meters, find the linear speed of a point on the rim of the wheel. So again, the fact that it says on the rim of the wheel is very important, so we know it's on the outside of the wheel, and that is going to be the full radius away. So the radius of the wheel is 0.5 meters. So again, our omega is 20 radians per second, our radius is 0.5 meters, and we're asked to find the velocity. Here we can use a formula from before. V is equal to R omega. So R is our radius, omega is our angular velocity, so we get 0.5 by 20, which gives us a velocity of 10 meters per second. So that's the speed of the rim of the wheel. Question 7, this is getting a bit more practical. A human body can safely withstand a sustainable acceleration of 9 g meters per second. What is the minimum radius with which a pilot can turn his plane if its speed is 500 meters per second? And you're told to neglect gravity. So again, this thing of g forces, this is something that you need to consider when you're doing piloting, especially in air fighter jets and things like that. So as you increase or fall, you will change the value of gravity on your body, because gravity will affect your weight. So as you plummet or as you climb or as you turn with this circular orbit, you will have a greater force on your body than just gravity alone. So to find out first off what the acceleration is, we need to turn these 9 g's into more standard units. So it's 9 times gravity meters per second squared. So gravity is 9.8, and we're told that at the start, so it's 9 times that. So the acceleration that the pilot will be facing is 88.2 meters per second. So that's the safely withstandable g-force, the acceleration force, the weight of the man. 88 point, not weight here, but that will get the weight. So 88.2 will be the acceleration. We then need to find the radius. So A is equal to V squared over R. So we can multiply both sides by R, then divide by A, and we get this formula written in terms of R. So R is equal to V squared over A. We're given our speed, 500 meters per second. That should be squared, divided by 88.2, because that's our acceleration, and we get this answer here at the bottom. R is equal to 2,834 meters. Again, just make sure that you square that R there. And our final question here is question 8. So the diagram shows a body of mass 0.24 kilograms attached to a fixed point P by a light string of length 0.8 meters. When the body is at A, which is vertically below P, it's given an initial horizontal velocity of 5 meters per second as shown. It then follows a circular path to position B, where it is at. So when it is at B, calculate first off the velocity, next the centripetal acceleration, and third the force exerted on the string by the body. So again, because it's a complicated kind of question, we're going to need a diagram to figure this out. So we have this point A, which is directly below P, and it's 0.8 meters away. So as we get this moving in a circle, this 0.8, that's going to correspond to a radius. Here it's given a push of 5 meters per second, so the force is in this direction. That force is going to bring it from here all the way up, so it's going to move. And again, it's going to move from a low position to a high position, so some of this stuff should be triggering the things you're going to need to solve it. So again, we have the mass we're given is 0.24 kilograms. Its length, which will be our radius, is 0.8. It's given the velocity of 5 meters per second, and it's going to move up there. So when it is up here at B, we want to find its velocity, we want to find the centripetal acceleration, and we want to find the force. So for part 1, what we need to do is, first off, we have the velocity at A, so that's 5 meters per second. The velocity of B, well, we can tell it's going to be slower, and the reason it's going to be slower is this is going to start off as kinetic energy, and as it moves up, it's going to be converted into potential energy. So there's less kinetic energy as it gains potential energy. So as with our conservation of energy, the kinetic energy loss is always going to be equal to the potential energy gained. This is again coming in with a bit of revision, and you'd expect that for the last question in the section, and it'll be something like you could get in an exam paper. So the kinetic energy lost is a half mv squared. The kinetic energy it has at A is a half mv squared A, and the kinetic energy it still has at B, because it doesn't tell us it stopped, it's just going to be less. It's a half mv squared B. So that's our kinetic energy loss. It has all its kinetic energy here, and it's going to have less up here, so the energy loss will be that difference. The potential energy it gained is going to gain potential energy by going to B, and that formula, as always, is mgh. So the kinetic energy lost, which is this here, is equal to the kinetic energy gained, which is this here. So we make these two things equal based on that principle. So half mv squared at A is minus a half mv squared at B is equal to mgh. It's the same mass all the way along, 0.24 kilograms, so you can just cancel those out. Then we do our bit of algebra. We multiply all of these by 2, so that will be double that. So v squared A minus v squared B is equal to 2gh. Then we're trying to find the velocity at B, so we're going to bring the velocity at A over, so that will come over as a minus. This here would also be a minus. Then we need to change our signs and get our square root. So we would have, as we change our signs then, so that's the way we have here, we change our signs, we go through our algebra, and we get the velocity at B is equal to 3.05 meters per second. I skipped a few lines here with my algebra. I think I might have made a couple of mistakes, but I got the right answer at the end. So that's the first thing. We've found our velocity at B, so that was what we got. Next we need to get the centripetal acceleration of the body. So again, that turns out to be a much easier question. We have the velocity at B, which is this figure here. We know the radius, which we're given, that's the 0.8 meters, so we can just apply this formula here. A is equal to v squared over r, which gives me 11.36 meters, and that's my answer for my acceleration. Then finally, I need to get the force exerted by the string on the body, so that will be your centripetal force. So force is equal to mass times acceleration. I know my mass, I was told that, 0.24 kilograms. I've just found my acceleration, so I multiply those things together and I get my 2.79 kilos. So again, we were given this 0.24 kilos. We didn't need it in part 1 because all of the mass is cancelled out, but we do need it to find the answer in part 3. So again, work through those questions, do some of them out, and make sure that you can get the answers accurately and quickly.